Record.
All right, should be recording now.
Off and running. Hi, everyone. As you know, we've tried to do this a couple times, but we're going to do a quick, probably half-hour show and tell on the NIST TCAMT tooling developed by the National Institute of Standards and Technology. There's really three parts. You can't really learn type TCAMT and work with it if you don't understand the IGAMP and even the GVT portion of this. I'll start with the IGAMP. A lot of you have probably seen other presentations that I've done regarding IGAMP, but I'm going to go ahead since we're all here and we have a couple of new folks as well. I'll kind of start at the basement level here and work our way up. As you're probably, most of you are familiar with, inside APHL, we have several different programs. We have the ARLN, the Antibiotic Resistance Laboratory Network. We have a COVID profile. We have vaccine preventable diseases, the VPD. We have rabies. We have the FLIP program, which is related to the flu influenza as well. We tend to use them interchangeably. Within ARLN, Amanda will tell you that there are yet another subgroups, including CRE colonization, DHQP, GC, Candida. There's an LRI program as well. So we have a lot of different implementation guides and data dictionaries that are affiliated with each of those specific programs. And each of these programs have their own inherent requirements. So what IGAMP does is allow you to author an implementation guide based on the requirements of each specific program. That implementation guide is then pushed out to the NIST, and Grace, this is for you, GVT, the General Validation Tool. This tool can be used in a context-free or a context-based environment, which I will go over shortly, to assist not only the APHL team, but all the jurisdictions as well with validating messages. I'm going to talk kind of slow here as I go through this. So if you guys, let me bring the meeting up. So if anyone has any hands, I can't quite see it. So Amy, if anyone raises hands and has a question, will you let me know?
Sure.
So yeah, feel free to interrupt me at all. So as we author these implementation guides, there are certain requirements that are general, which would apply to every base program. And you can see here, we have an ELR foundation program. This is where we start when we build an implementation guide. These foundational profiles allow us to take what is the standard for ELR, and then from there, we customize it for each program. And when I say ELR Foundation, we all know that we have very basic context to our messaging profiles. We know that we have an MSH segment. We know that we have SFT, OBX, OBR, SPM for specimen. We're all probably pretty aware of those. And in this foundational message, there are also cardinality rules, usage requirements, as well as length. The data types, as well as the value sets, are often also listed in these foundational profiles. So we always start there. We get the foundation profile built so that we know that we're going on a national standard. And then from there, we will look at each individual segments. We can start down here with MSH. So we would look at MSH On a side note too, if you'll look here on this segment, there are two different colors here. So any of the ones in this, I'm going to say salmon color, those are standard segments. They're not allowed to be modified, and they can't be modified. They're restricted. So if you need to modify a particular segment, you would go to the basic, the salmon color, and you would create a flavor. Doing so would then allow you to customize it. And all the ones that are customized, normally I put an ELR beside them, or if I'm customizing them for a specific program, such as the HHS program for COVID, then I would name it appropriately. All the ones in green have been modified and they're custom. That's a really good way to separate these out. So what you're trying to do is put together an implementation guide that correctly reflects what is needed for that specific program. So we can look at a specific program and we know that this MSH now has been modified. And maybe a program like rabies might use a standard MSH heading, and maybe only one or two programs need the MSH, but as long as one program needs it modified, I have to create a new one. So this MSH ELR is going to differ from the basics. So when we look at this MSH ELR segment, we know right away that somebody customized it. So then we can come over here and we can look at the MSH segment. And just by looking through the data types, which are listed below the segments down here in a very similar layout, we know that the data types that are green have been modified. And we know that for two reasons. We know because it's green, and because in my case, I always put ELR after them. I could have put APHL or edited anything, but when we first started, that was kind of the naming convention that came up. So that's what we've kind of held with. So you can also, by looking at MSH, when it comes up here on the table again, you can look at cross references up at the top, and you can tell which programs use this specific flavor of MSH. So we can see here that GC, Candida, rabies, VPD, the opiates program that we wrote a little while back with Emily's help, as well as the HHS or COVID profile, all uses this segment. So you can't delete it or remove it because everyone is using this particular flavor of a segment. So you can go back to your definition, and in doing so, you can look at certain criteria. For one, we use conformance statements, and I'll kind of lead into TCAMT with this because you have two options when you author an implementation guide. You can connect it directly to the GVT. The GVT will accept the program on a context-free, let's just go to VPD here, a context-free validation. So if you export something directly from IGAMP to GVT, you can perform context-free testing. So context-free and context-based is kind of what we're going to talk about, because in order to have context-based testing, you have to author test groups, test plans, test steps, test cases, utilizing TCAMT. It's kind of an intermediary. So if you think of IGAMP, I guess one analogy would be this is kind of high school, but if you're going to get to the college level, you kind of need to understand TCAMT in order to really get to the next level of method validation. So when we are back in IGAMP now, and we send directly to GVT for context-free, we're still validating messages, but we're really looking at much more of a structure. We don't necessarily care specifically what vocab groups and terms are used specifically. What we're looking at is, we're still going to require a SNOMED code for certain fields, LOINC codes in certain combinations, but that's where it kind of ends. And I'll explain a little more of that later. So when you go directly to GVT from IGAMP, you're looking for conformance statements. You're looking at the structure. If field 1 is required, the message will fail if it's not there. It doesn't care what's in it per se to some degree, which in this case it does, but a lot of these, if it's just required, it's just going to look for it. And the conformance statements that we author will help in that validation. We know that the value of MSH1 has to be a pipe. We know that value of 9.1 MSH should be ORU. So these are the common restrictions that if the message doesn't have, it will fail right off the bat. So this is more looking at characters, specific formatting. It might say this field is required to be a LOINC code. The coding system should be LN. And if it is LN, then it needs to be formatted in a specific way. Dates are like that too. If there's a date field, you can see here that 7.1 has to be in a certain date format to a certain decimal. So these are all called regexes. They're regular expressions. Some of you may have written some of these before, but inside IGAMP, when you are looking at special formatting, you have to author these regexes to validate time. Another common field would be looking if you have a specific OID and if it's documented correctly. Do you have the right amount of characters in it? So these are the types of things that GVT will look for. You can also load specific vocab into the back of the GVT, and it will validate if you have correct LOINCs and correct combination. If you have a specific order LOINC, you may have 7 different result LOINCs that you can use to result out. So we can do some vocab validation, but most of that is done on the backside using specific plugins that NIST has to help the APHL team with. The reason for that is the IGAMP has a limitation of 500 values in their code sets. So if you are looking at influenza where you have 800 or 900 code combinations, we can't utilize IGAMP to develop those code systems and push them to GVT. So it can be done, but it has to be done on the backside. So that's kind of the, I guess, entry level for IGAMP and GVT, how those are connected and how they use context free. So I will move on to context based unless anyone has any questions. Okay, I will move forward. So in order to perform context-based, you have to author test cases in TCAMT. So what we're doing previously, GVT directly from IGAMP only looks at code combinations. What we want to do is tell a jurisdiction that, yes, we want this code combination, but we also want a specific result or results. And if you don't have that, the message will fail. So this helps validation when you have, Amy, help me out here. How many scenarios does influenza have?
Oh gosh, it depends on the lab.
Exactly.
Get up to 80, 90.
Okay, 80. So we have 80 messages that need to be validated prior to a jurisdiction upgrading and going into production. So as you can imagine, looking at those 80 messages and trying to determine, did they send a positive A and a negative B, and then a negative B and a positive A, and then 2 negatives, 2 positives. Within that, they may have to send one that's positive, negative, 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 specimen unsatisfactory. It gets really confusing really quick. And right now, outside of GVT, it's a very manual process to provide feedback, run it through GVT, and go back and forth. So ideally, the jurisdictions would be able to go to the GVT, put in their message based on a specific test plan and test case, and even perform the validation themselves. So in TCAMT, we would be the ones that authored and tweaked the implementation guide to make specific test cases for message validation. So the first step when you're developing a test plan for TCAMT is to import the IGAMP implementation guide that's already been authored. So we have a way to export these, and you can export them directly as XML files. You can connect across to GVT directly without having to export them. And in TCAMT, you can also import a new implementation guide. That is always going to be the best way to do this, to kind of get your, let's say, the COVID plan. When we author that, you would import it here, and then that allows you down here to either export it, to copy it, or to edit it. And each user has their own test plan. So when Doug needed to make some adjustments to this, he can't really adjust mine. Each one really has its own user ID. So one thing you could do is export your profile or export the IGAMP and share it with another user, and then they can load it into their own TCAMT, and then they can start making modifications. So if 2 people are making modifications, it's not a real-time shared drive or SharePoint, anything like that. It's in its own pretty much sandbox. So you can manipulate it, do what you want, and it will not affect any other users. So once you import your profile, you can start building out your test plans. So one advantage of this is you can do each result that you need individually. As you can see here, I'm going to close some of these out. So when we first started trying to develop a context-based TCAMT profile to export to GVT, we started with a test plan, which was COVID-19. And you can kind of see the abbreviations here as well for test plan. And then the test groups. So we came up with 3 groups. We knew that we were going to do conclusion reporting, target reporting, and target conclusion reporting. And under each one of these, we knew, and again, you guys, bear in mind, this is about 2 years old, and thank you to Amanda for doing all of these. So some of these are now going to be out of date. We never really went into production with this. So some of these will be outdated, but you can see we knew from the beginning that we would have certain test cases that we wanted to run through for any laboratories that were using the Abbott Architect. We also had the Abbott ID Now. We had the real-time assay, and you can kind of just go down the list. And I know Jerry will tell you from his lipid work, this is probably exploded. But at the time, we had about 39 specific assays that we were going to be testing. And we knew we wanted specific scenarios brought into this. So for Abbott Architect, we knew we had two, what we are calling test steps. Those are the specifics that you're testing. We would have one positive, one negative. The Abbott ID, they reported out as detected, not detected. They also had an additional reporting parameter as specimen unsat. I think there was one that had 4. Yes, so some of them also had a detected, not detected, presumptive positive, and then specimen unsatisfactory. So as you build out your test group of all the conclusion reporters, you would then create a test case for each specific test that you're looking at. So in this case, we were looking at the Abbott Architect. So then you go to the package insert, you determine that they're going to be reporting out positive and negative. Same with Abbott. You would look at detected, not detected, specimen unsat. So what we do at this point, we start building out the test step. So in order to do that, you have to have a little information and you have to know what the specific message looks like. So you start by creating the metadata. Almost all the work we do are profile based. That means we've imported our IGAMP profile and we are going to use that as the basis for data validation. For our message profiles, our also profile is the ORU message profile. So we choose that as well. Then we can start to develop a test story. We can come up with a description. So my description for this test is this is used to report conclusion results of detected using the Abbott ID assay. And you can imagine the next one I wrote says used to report conclusions of not detected. And each one has its own specific story. Most of these fields are not required, but I always like to put a description just so I know what we're doing, but you could add your own comments, preconditions, post-conditions, objectives, what you hope to achieve by creating this test story, and what your criteria is, what you are considering, what should pass or fail. But again, these are all just a notes section. So you can start off by taking a good crafted Abbott ID message with detected in it. So you can start by loading it into the encoded message profile. And from there, it helps develop the test data that you need to perform a validation. So we know that this Abbott is going to be reporting out this specific LOINC code. So we will always look for 94534-5, and we will always look for a result of detected. So previously, when we went from IGAMP to GVT, we might be looking for a code combination of 94534, and maybe we were looking for a result here, but we don't necessarily look at what the result is. As long as it's a valid SNOMED and it's part of a predetermined value set, then we would take detected, not detected, but then we have to figure out on our own which scenario the client's message goes with. Here, we don't have to do that. We know that if we run this message through and it passes with 0 errors, we know that the client sent us the correct LOINC code, they sent us the correct detected, and then we can move on. We can pass that and move on to the next one. So it takes a lot of, I don't know, the grunt work, I guess I should say, for anyone that does validation. So eventually, to get to the next level, we would need TCAMT profiles for every, like Amy said, for flu, we would have 80 possible scenarios. And we might not always look at instrumentation because that's going to vary. And, you know, most of the times that's not something we're going to validate, but we would want to validate certain code combinations with certain answers. So again, it just kind of puts us up to the next level. And you can load a test message, but then you can also manipulate it to whatever requirement you want. So as we move along building this test step out, we started with the metadata. We put a few notes on our test story. We loaded the HL7 message, and now we're going to the test data. So by loading this message, it automatically loads these segments in here. So here we have the MSH. We know from the implementation guide that the usage is required. So we always need this MSH segment in here. We know we have the SFT, we have the PID, the ORC. So as we move on down and we want to look at specific OBRs and OBXs, then we can manipulate this message even greater. So let's say I'm going to pick the OBX here. So this, by selecting this segment, it now opens up all the OBX fields. So we know from the message that we are going to be looking for this particular LOINC code on every message that comes in. We know that because over here, the test data category is fixed. It is not an option. So we also, you can tell that we're not looking at the text because there's no specific data category. We don't necessarily validate against that because we are just looking for this specific code. So if they sent the short name or the LOINC long name, it would not flag. We can also adjust these. These are all programmable. So if we wanted to change this over here, you could say that we're indifferent. We don't care what's in this particular field. We can look, we just want it to be present. We may just want to look at the length. We can do a test case fixed, or we could even do a list. So if we know that this code could be coming in as a LOINC or SNOMED, we can add additional fields here. So we can, well, I'm going to leave that little. So we could add additional fields. I don't know if it'll let me, it's just a bad lag. So we'll just leave it for here. But really, we can change it to be whatever we want. It has to be fixed, or it can be fixed, but it could also be one of these listed characters. So we can go in and manipulate every single field that we do. And once we export this to GVT, we still have the basic rules of length, the conformance statements. We still have all those in place that we were looking at earlier in GVT. But now we have a little more customization here. We can make this pretty much say anything we want. We can make it any specific code. So here, if you look on all these messages that are tested with this test step profile, we're looking for this specific link, and we are always looking for this specific identifier. And we know that because it's fixed. There's no list here. It's not like up here where you could have different choices, detected, not detected. So it will always be this specific code. Anything else will cause an error and cause the message to fail. Any questions so far?
Are you able to validate two separate fields of the same list? Like, for example, if labs, instead of putting in the standard code in first triplet, they put in the second triplet, could you write rules where you check for that line code in either 3.1 or 3.4?
Yes, and that would be done on the IGAMP side.
Okay.
So, but again, if you wanted to, we could still, you could change this to presence, I believe, and then we could probably put it down here as well, Amy. I would have to experiment, but most of these rules, where are we at? Value case fixed. So we could put this in here again. In this current scenario, though, it would have to be in both,
Right.
or it would fail. But using the conformance statements in the IGAMP, then we could write, look for this in either triplet. And then we could come over here and put this in.
Okay.
So yeah, it's a high degree of customization, but sometimes it's mixed between
The two.
IGAMP and TCAMT. Yeah,
Okay.
unfortunately. Ideally, they would merge this, but they haven't yet. Is somebody else going to say something?
Yeah, Jamie, I'm sorry. When you made the changes, because I've been playing with this week, this portion here. Right. So, okay, we know you had the initial version for LN. So if you want to say you're going to send a message with SCT, the additional values that you have, does the encoded message, the HL7 encoded message, have to be changed to SCT as well? Or
no, it doesn't. It doesn't. It's just a basis to help you get the information in here initially.
Okay, so what we're doing is once we get it to GVT, if they send LN, SCT, or P, that's how the validation is allowing it versus having it static as a fixed code for LN.
Right, right.
Okay,
yeah. Yep, okay. Yep, that'll work. That'll work. But yeah, you don't have to go back and update the message.
Okay, great.
So you can, obviously, if you want, but that's just to help you get all this information in here and not have to start from scratch. Does that answer your question?
Yeah, because I know now the more I build out, like if I'm doing species, I need an actual HL7 message with all the species I'm adding to this field.
Yes.
Okay.
Yeah, ideally. So when we go back and look at this message, you can see you have a detected one here. So the next one we have is going to show up and it should be non-detected. So, and then the next one is going to be specimen unsat, which is right here.
Okay. Yeah, I just wanted to make sure. So when we do pull it to GVT, I didn't have to make an additional message because I do have detected, not detected, all of these different test steps. But if we're changing, like I said, species from like cat and dog, I need to have additional messages. So when I run it over there, it would pass. Not just to stay on cat, it will go to dog as well.
Especially if you're going to be testing your messages, then you would need a good message. And that's kind of what we'll get to here in a minute, actually. So, yeah, that'll be a good segue into the next topic. So I'll kind of wrap this up. So anytime you need to make any adjustments, you can go in and select whatever segment you need to be in. I don't think there's too much information that we don't really utilize these as much. So really the segments list is what you're going to use to change anything. You can clone these. So if you wanted, everything's exactly the same, except you might going to change one other piece of it, then you can just clone it and rename it. And then you could go in and tweak the segment that you needed, especially if you didn't have like 3 different messages. If you just had one, you could clone all these and then change what you needed. And then you could go back to your message as well and import the same message over and over, and then just change the segment that, to reflect the changes you just made, like you were talking about, Pam. So once you do all of this, you can actually validate your own message in here and test it. So here we have a context-free, and it passed. You can also do context-based. And it passed as well. So if you go in and change a couple of items, I don't think I have this set up. Let's see. Yeah, I don't have this set up to test context based on this platform. But once you go in, and there's some more settings I would have to do. I don't use this, but you can just do a quick validation in context free. Context based right now is not set up on my profile. Here is actually the XML code as well. If it needed to be manipulated, you could actually, export this and manipulate it as well. And then you can load XML coding into GVT if you needed that. I just got the 15-minute warning or 5-minute for our meeting. So I'm going to switch over. So once you author all these test groups, test cases, and test steps in TCAMT, then you're going to connect with GVT and push these over. So now, just like that, we're in GVT. And instead of where a lot of people use context free with all the different profile groups, we're going to go to context based. Since we've been talking about the COVID one, I'm going to go ahead and keep using that. So right now we're looking at Thermo Fisher. So if we know we have a jurisdiction that's going to be reporting 4 different scenarios out of Thermo Fisher, you would go in and you would locate the specific assay you want. And then you're going to come over here and you're going to load the test case, because we imported all the test cases from TCAMT. So now we know that we have 4 different scenarios. So now you can validate all 4 right here. I think the saying is one fell swoop. I'm not sure what that means, but I think that means everything. So you can do them all here. And that way you're not going back and forth and trying to determine if anything passed or failed. Pam, you were also talking about the messages. So here we've loaded each of the sample messages into the example. And that's a really good thing to have, because it's kind of like a little quality control check. So if you put your message in here and validate it, it should go to passed up here. I mean, if it doesn't, then you've done something incorrect. So it's a good way to test before, because we probably all have done it. You've put a message in fully expecting it to fail, and it doesn't. Or you look at a message and you say, yeah, this is good, and you pass it, and then a very similar message comes in production and it fails. So, and that's usually because something with a GVT isn't correct or has broken or not been entered correctly in the first place. So this is a good quality control to throw your example in here, validate it. Yes, it passed. Well, let's take out this one here. Let's take this character out and let's validate it again. Okay, so now the message has failed. We come down here, we have one error, which is a content failure, and it's telling us content. You have invalid content based on the test case fixed data. And this test case fixed was the dropdown that we chose. And we told them that in 5.1, you can only have this code. So no matter what we change this detected code to, it should fail if it's not explicitly the number we gave it. So I'm going to add the 1 back. I'm going to take detected out. I'm going to validate. So in TCAMT, we didn't specify what it had to be. We didn't say it had to be the word detected. We could do that. We could spell it out exactly if that's going to be a requirement for that program. But if not, we're not really validating that at all. Same with SCT as it relates to TCAMT. A lot of rules in IGAMP will still apply for certain code combinations and length and things of that nature. But for context-based, we're really looking at specifics that we programmed. So once you do this one, you can comment on it. You can also say, you know what, there's an exception here. We're going to go ahead and allow it to pass. Or if they're missing data, we can do incomplete, inconclusive. We can override the test step if we want. In this case, it passed. We're going to go to the next one. It's automatically going to default to not detected. In this case, we happen to have an example, so we're going to load it. And it automatically validates it and goes to passed. So again, we're looking for not detected. So if we delete a couple of these trailing zeros and revalidate it, it's going to fail because it's missing this specific code. And now it automatically went to failed. So when we go back and make this modification, and you can set this to auto validate or just validate by clicking the button. I prefer to disable it. So we're going to validate, and there are no errors found because we have the not detected here that we want. We also have this specific code. So if we get rid of the LOINC code, it's going to fail because it also knows that we are looking for one of these 3 LOINC codes in 3.1. So that is our test case fixed list. We can list these specific codes. We don't necessarily care which LOINC they use when reporting out not detected, as long as it's one of these 3. It's also telling me that you told us you're going to be using a LOINC code, LN, and we see that. But the LOINC you supplied is not formatted. And here's another regular expression that we had to write specifically to represent what a LOINC code should look like. So it knows also that this is not in the right format. So we're going to put this back. We're going to validate. It's going to go to passed. We're going to say, oh yeah, there was a notable exception, and we can do that for whatever reason and go ahead and let it pass. Next, we're going to go to inconclusive. We're going to load the example. We're going to validate it, and it passed again. And if you look down here, we have inconclusive. So now we're going to go to the last phase here. We're going to hit our next button. We're going to load our example, and it passed. And it should say specimen unsatisfactory, and obviously since it passed, it says it here, and it did pass. No errors in this message. So now we can look at our test summary, and it's just going to tell you right here that everything passed. So your test status overall is completed and everything passed. You can then download a specific test case report. So you could also put a comment and put, this is for Washington State, all passed. So you can put notes and then you can download specific test case reports. So I'm going to go back here to test selection. And again, kind of show you of all the work that was done here. And we're getting close to the top of the hour. So I want to kind of stop here and see if anyone has any questions. Did I confuse everyone so much that they don't know what to ask?
This is awesome. It's getting me further.
Okay,
Yeah, it's awesome. It's very, very, very good.
good.
Yeah,
Thank you,
for
Jerry.
walking through that. It's very clear.
Yeah, no problem. No problem. I guess we can stop recording then, Amy.
Okay, well, Andy said where to start.
Oh.
I do have a question, Jamie. Do you happen to know just offhand what the general differences are between the original IGAMT and the IGAMT 2?
Yeah, and I think there might have been a release, but authoring, regular expressions and conformance statements are much improved. Currently, when you write a conformance statement in IGAMT, if you have to modify it in any way, you can't. You have to delete it and start over. Another feature, the conformance statements in IGAMT 2, you can actually disable them temporarily, which is huge because the only way you can disable them on the other side is to delete them. And then you have to copy them, put them in a WordPad and try to remember them if you're redoing it. So you can manipulate those much better. The regexes are also written for you in a lot of the formats, so that you don't have to come up with those anymore. So those are some, just off the top of my head, those are some of the features. We're supposed to be migrating everything to IGAMT 2. And as you know, you cannot import anything into there. So you have to start from scratch on all the profiles, which, as you know, you had to do. But there may be a release document, I think, that NIST has, and I might try to get that if they have that, and I'll get that to you, Doug.
Okay, thank you.
Yeah, it's much easier to use. It's a lot less restrictive, but the bad news is you have to start everything from scratch. Anyone else while we have a few minutes left? All right,